Have you ever wondered how your computer can run a game, a web browser, and a music app all at the same time without crashing? It's all thanks to a clever process inside your operating system called the CPU scheduler. Think of it as the traffic cop for your computer's brain, directing which task gets to run and when. But not all traffic cops work the same way. Is it better to be fair and serve tasks in the order they arrive? Or is it more efficient to let the quickest tasks cut in line? In this video, we're going to find out. I built this web application to bring these concepts to life, and we'll use it to compare three famous scheduling algorithms: first come, first serve, shortest job first, and round robin. To make this a fair fight, we'll use the exact same set of 4 processes for every test. You can see them here: P1, P2, P3, and P4, each with its own arrival time and the time it needs to run, called the burst time. We'll also keep the system configuration the same for each round. We're simulating a modern dual-core processor, so we have 2 CPUs ready to work. Our goal is to see which algorithm can complete all these tasks with the lowest average waiting time. A lower waiting time means a more efficient and responsive system. First up is first come, first serve, or FCFS. It's the simplest of the bunch. Just like a line at a coffee shop, the first process to arrive is the first one to get served, and it runs until it's completely finished. No cutting in line. Click Run Simulation. Okay, the simulation is done. Let's look at the Gantt chart. P1 and P2 arrive first at 0 mems and 1 mems, so they immediately grab a CPU each. P3, which arrived at 3 mems, has to wait until P2 is done at 4 mems. It's a very straightforward process. But look at the results. The average waiting time is read the actual value from your simulation. FCFS is simple, but it can cause a problem called the convoy effect, where a short process gets stuck waiting for a long one. Next, let's switch to shortest job first, or SJF. This algorithm is much smarter. It looks at all available processes and gives the CPU to the one with the shortest burst time. We're also using preemptive mode, which is a game changer. It means if a new process arrives that's even shorter than the one currently running, the scheduler will pause the current one and switch to the new, shorter job. Click Run Simulation, and done. Wow, look at that Gantt chart. It's completely different. The scheduler intelligently runs the shorter jobs first to get them out of the way quickly. This is much more dynamic than FCFS. Now for the results. The average waiting time has dropped to just 0.5 minutes. That's a massive improvement. SJF is proven to be the most efficient algorithm for minimizing waiting time, but it does have a weakness. A very long process could potentially wait forever if shorter jobs keep arriving. This is called, finally we have round robin. This algorithm isn't focused on being the fastest, but on being the fairest. It gives every process a small, fixed amount of CPU time, called a time quantum. For this test, we'll set it to 2 milliseconds. After 2 mems, if the process isn't done, it gets sent to the back of the line, and the CPU moves to the next process. This ensures everyone gets a turn. Click Run Simulation. Okay, check out this Gantt chart. It looks chaotic, but it's actually a perfect example of fairness. See how the CPUs are constantly switching between P1, P3, and P4? This is why your computer feels responsive even with many programs open. No single program can hog the CPU. Looking at the results, the average waiting time might be higher than SJF, but the key benefit here is responsiveness. Round robin is the foundation for most modern schedulers precisely because it provides a smooth user experience.
So, after 3 rounds, which algorithm is the best? The answer is, it depends on what you need. First come, first serve is simple but can be slow. Shortest job first is the most efficient, giving the lowest average wait time, but it risks starving long jobs. Round robin is the fairest, providing the best responsiveness for an interactive system. The best way to truly understand these concepts is to experiment yourself. I've put a link to this scheduler in the description below. Go ahead, create your own processes, change the number of CPUs, and see how these algorithms perform.